Hello folks, I am Yashwant Kanetkar. In the past also we have experienced that everything internally is treated by Python as an object. Time has come to prove this to you. So we will take a few simple objects first. Maybe we say I equal to 20, then j equal to I. Now I holds 20 and I is actually referring to a nameless object which contains 20. When I say j equal to I, realize that I am not copying 20. Whatever reference, whatever address is present in I, that address is being copied into j. It means what? By saying j equal to I, you are merely creating one more reference which refers to the nameless object which holds 20. And I am not restricted to creating only one additional reference. If I so desire, I can create yet another reference by saying k equal to I. If you print out the addresses present in I, j and k, which you can do by making use of the built-in function called id. When you do that, you will find that I, j and k all report same addresses, which goes on to prove that same object can have as many references as you wish. So one object and multiple references is very much a reality. If I say k equal to 30, now what happens? By doing k equal to 30, k now starts pointing to a new object which contains 30. Whereas I and j continue to point to the old object which was having a value 20. So if I say print k is bound to print out 30, whereas ij would remain stationed at the object which contains 20. Is this okay? So one object, multiple references is very much possible. Let me give you another example where we create an object containing 20, its address we store in x. Then we say y equal to 20. X and y point to exactly the same object. Means the moment it finds that there is already a nameless object containing a value 20, it doesn't bother to create one more. It just assigns the reference of that existing object containing 20 to a new variable y. If I now say x equal to 30, now x would start pointing to another object which contains a value 30. Whereas y continues to point to the nameless object which is holding 20. Thirdly, if I create a sample class and then I try to construct object of the sample class by saying sample 10, 20 and one more time sample 10, 20. The treatment that is meted out, the treatment that is given to 20 is different than the treatment that is given to the sample object. Here, since 20 and 20 are same, x and y point to the same object, but that argument does not hold good here. Even though the object is going to contain 10 and 20, they would be treated as two different objects whose addresses are stored in x and y. Again, using the id function, you can print out the addresses present in x and y and get this verified yourself. Fine? Okay. Now, saying that everything is an object needs a proof, and it's time to give you that proof. For that, what I would do is, I would create all types of variables. Firstly, let me import the math module and then declare a class called message, which simply has a function called display, which prints out a message, and then we have def1, which is outside the class. So it's a global function which just prints out another message. And then I create an integer object, store 45 in it, store its reference in I. Likewise, I create one more float object, its value is 3.14, its address is stored in A. Then I create a complex object by saying 3 plus 2j, where 3 is its real part, 2 is its imaginary part. And then store the address of this object in C. On similar lines, I create a string object store its address in city. And then a list object containing 10, 20, 30 and address of this object as storing LST. Same thing I do for a tuple, then a set, and finally a dictionary. So far these are the ones that we have created. Standard types, user defined types, then a user defined class, a user defined function. So all these we have created. Let's now try to print out the type of each and the address of each. We can do so by saying print type of I and ID of I. Same thing I can do for A, C, city, list, tuple, set, dictionary. Fine. In addition, I may also say get me the type of fun, get me also ID of fun, where fun is your global function. Same thing I can do for the class. So also the math module. When I execute, this is the output that I get. Now what you can see is that everything is a class. Every type is a class. It means when I say I equal to 45, integer classes object gets created. It's a nameless object and its address is stored in I. By printing out ID of I, you are printing out this address 4952458808. This is the address that gets printed out. Fine. Similarly, when I created a float object got created, its address got stored in A. That's the address that is being printed out. Fine. Same is true for every other type. Float, complex, then string, list, tuple, set, dictionary. Then a function, which is also a type. Type itself is a type. Class can also be replaced by type. And then module also happens to be a class, which goes on to prove that every single entity that you create in Python is essentially an object of some or the other class. In that sense, it's a truly object-oriented programming language. Goodbye and good luck.